After covering the topic Biot-Savart law and its application, now it is time to introduce a new topic, that is Ampere-Circuital law. This Ampere-Circuital law is equivalent to Gauss law of electrostatics. If you remember Gauss law of electrostatics, that was integration of E dot ds is equal to 1 by epsilon naught times the charge enclosed by that surface. And to find electric field intensity, we were assuming some imaginary surfaces known as Gaussian surface. Here also, to find magnetic field around certain surfaces, we assume imaginary surface known as Amperian loops. So the statement of Ampere-Circuital law is the line integral of magnetic field around a closed loop is mu naught times the current enclosed. So the mathematical form is integration around a closed loop is equal to integration of b dot dl, line integral b dot dl is equal to mu naught I. Suppose there is a circular loop in which current I is flowing. It has been considered that this circular loop is made up of many small length element, that is dl. There are many length elements whose length is dl. There are many length elements. This whole loop is made up of small length element whose length is dl. So total magnetic field around this loop would be b dot dl is equal to mu naught I. This is Ampere-Circuital law. Now we are going to do proof of Ampere-Circuital law. So for proof of Ampere-Circuital law, let us take an infinite long straight conductor in which I current is flowing. Okay. We will consider an Amperian loop around it, and that too in circular form. Let this be Amperian loop. This imaginary loop is known as Amperian loop. You can note down that, like in Gauss, it was Gaussian surface. Here, if we assume any loop, that is known as Amperian loop. So I current is flowing here. Let us take its radius to be r. So let its radius be r. This radius of Amperian loop is small r. Let us mark one length element. Let us take this as dl. Now, if you see the current is flowing in upward direction, if you apply right hand thumb rule, the magnetic field would be like this in circular form. So magnetic field would be like will be going like this in same direction with length element. Okay. So if you want to calculate line integral, that is integration of b dot dl, as it is a dot product, it would be b dl cos theta. Integration of b dl cos theta. Theta is 0 over here because they both are in same direction. So cos 0 is 1. So it would only be b integration of dl. Now length would vary from minimum to maximum. Minimum length can be 0 and maximum length of this dl can be whole loop, that is 2 pi r, that is the circumference. So this would be b into l and 0 to 2 pi r. So this would be b into 2 pi r. Now if you have seen that last video of infinite conductor, what was magnetic field at this point? That was mu naught I by 2 pi r. We have done this derivation. So value of this b is mu naught I divided by 2 pi r into 2 pi r. So this 2 pi cancel and you get integration of b dot dl to be mu naught I over a closed loop. B dot dl is equal to mu naught I. So this is the proof of Ampere-Circuital law.